Perfect. So Joe is here, you are here, we can begin, and thank you so much. So it's a great pleasure to introduce Professor Joseph Manning, the William and Marilyn Simpson Professor of History and of Classics at Yale University. Joe, I hope I may, was educated at the Ohio State University and at the University of Chicago, which included a year-long American Research Center in Egypt fellowship that allowed him the opportunity to live and travel throughout Egypt, and a year studying at Cambridge University. At Chicago, Manning studied Egyptology and ancient history, taking MA and PhD in the Department of Near Eastern Languages and Civilizations. His research has two primary research foci: the economic and legal history of the Hellenistic world, with a focus on Ptolemaic Egypt, and Egyptian history in the long run. At Yale, he is, as I said, the William and Marilyn Simpson Professor of History and Classics, with appointment also in the Department of Near Eastern Languages and Civilizations, Yale Law School, and the School of the Environment. Manning's work now takes him in some new and, as we will see, exciting directions, including working on climatic change. Nile River flooding and societal responses with a major grant from the US National Science Foundation. This project examines the link between explosive volcanic eruptions and the annual Nile River summer flooding in antiquity. Large volcanic eruptions can reduce average global temperatures and suppress average global precipitation. This is known to have had dramatic effects on annual rainfall on the Nile watershed in historic times. Human responses to the annual flooding and to its variability over the years was the major driver of Egyptian history up to the completion of the High Dam at Aswan in the 70s. This project will capitalize upon a rare confluence of natural and human archives for ancient Egypt and the Near East, by comparing rich historical records, papyrus documents, and inscriptions with environmental data and regional climatic and hydrologic simulations for repeated abrupt climate events. The research will determine whether and how social dynamics are climate-driven, and whether and how human water management affects regional climate and hydrology. So we will end with this, and we'll hear much more about this from Professor Manning himself. Thank you so much for being with us.
Good afternoon. Thank you, Amir, for that wonderful introduction. Hello, everybody. It's a wonderful crowd, I can tell. I wish I were with you in person. I'm honored to have been invited. I'm looking forward to your comments in a little while. I hope you can hear me okay. I'm going to share my screen and go through some PowerPoint slides, introducing our project, essentially, and then some specifics that I think might be relevant to your seminar. So off we go with the slides. I'm going to focus on the 2nd century BC at the end of the talk for reasons that will become clear in a moment. So let me start by talking briefly about the Yale Nile Initiative, that I call it, which is based at Yale, but we have partners all over the world now that are cooperating with us, that are working directly on the project or indirectly, sponsored by National Science Foundation here in the States. And we are part of what is called the Volcanic Impacts on Climate and Society Working Group, VIX, sponsored by Pages and Bern in Switzerland, which has been a very productive group of scholars, climatologists, volcanologists, archaeologists, historians, sort of across the board. It's really wonderful collaboration. And I'll maybe talk more about that at the end of the talk here. We're a small group. Normally we're meeting by Zoom now, unfortunately, but one of our main partners is in Dublin. And so this is just a few of us, climate modelers, paleoclimate scholars, geochemists, and historians, We have met in Dublin quite a bit because on the far right, Frank Ludlow, one of our main partners, is based at Trinity College now. And it's a wonderful place to host, and it's sort of a central place for us that we hope we get back to in normal times, the God's willing. I just list the team there for reasons of reminding you all and myself too, that this is a group project. No one person can do this work. And so I really am representing the team and everything I'm presenting. I'm here, but normally these all the work is team related in very exciting ways. We work within what is typically called coupled natural human system dynamic modeling between climate and society, environmental change, climatic change, and human responses. This is, I think, a standard way of working. It's not a standard way of ancient historians working, though, and it's actually quite challenging to work in this kind of coupled system dynamic way, particularly trying to get the feedbacks, negative and positive feedbacks between natural and human systems in both directions correct. It's actually extraordinarily challenging, and we continue to talk about it and work on it. Again, we are a small group of about 8 people and a couple of postdocs now and a team of undergraduates here at Yale working on the history side of things, hydrological modeling of the Nile River floodplain, climate modeling, more globally, looking at societal responses from short-term events to longer-term feedbacks that we hope we can see, even in the archaeological record now, and statistical analysis that links the historical and the climatic data. Again, all of this is sort of challenging, but we have several different sort of sub-projects that we're now integrating in the next 18 months or so as we start to publish some exciting work. So that's the background of the Yale Nile Initiative that I'm leading here at the minute. Now, one of the things I've learned, of course, I study the Nile River, as Amir said, as everyone does who works on Egypt, of course, and I thought I understood how the Nile River worked, but the project starting 6 or 7 years ago now really has shown me that I understand very little about Nile River dynamics. It's actually an extraordinarily complicated climate system with 2 main drivers at the Great Lakes region at the equator, the White Nile, which contributes the bulk of the water at the low stand of the river. So not really important for the agricultural cycle in Egypt, but it is important in other ways. And the Blue Nile system based in Lake Tana in the Ethiopian highlands, which contributes something like 70 or 80% of the Nile River flow in the summer months, which is in Egypt, driving the agricultural cycle. So 2 basic climate drivers, but it's more complicated than that. And if there's questions at the end, I'm happy to talk a little bit more about that. But we're actually finding some new climate dynamical information just through the project, even in the historical record, which we hope the climate scientists and climate modelers can help us explain. So the annual river flood in Egypt is driven by the monsoon, the intertropical convergence zone, as it's called, this monsoon rain belt around the world, just north of the equator, which migrates northward in the summertime for complex geophysical reasons. And you can see it migrating here northward. If you can see my arrow, it hits the Ethiopian highlands with annual rain normally in June. And this movement from the south around the equator northward every year is, of course, the monsoon cycle, not only for the East African monsoon, the driver that I'm concerned about, but for the South Asian monsoon, for the East Asian monsoon. They are linked. And we actually are finding some interesting historical linkages, which we're just beginning to explore. So this basic movement of the intertropical convergence zone is essentially Egyptian history before the high dam was constructed at Aswan in the 1960s. The annual response to the monsoon rains and the flood of the river is essentially the most important dynamic, certainly within Egypt. When I was an young grad student in early days, a long time ago now, I read Karl Butzer's great book, Early Hydraulic Civilization in Egypt, published in 1976. And this is a pioneering geoarchaeological treatment of the connection between the flood of the river and human responses, the agricultural cycle, how the agricultural cycle works, what sort of crops are grown where, and so on. I give you the table of contents on the right. You probably all know this book. What's remarkable about this book, such a pioneering book indeed, is there's virtually no science in it in 1976. And that's a real measure compared to now of the scientific data that we have in increasingly high resolution. This is really kind of driving all this exciting work, not just in our group, but groups around the world now, and quite a change. And it's interesting to go back to Butzer's insights in the 1970s and tie back in the insights, essentially, the connections between longer-term political, what he called political discontinuities, and the annual flood of the river and decadal and even centennial river flow. So river flow at different scales, which is how we're trying to work now, because we can work that way now, given the tools that we have that the great Carl Butzer didn't have, but he had these interesting insights. There is a literature now that connects large volcanic eruptions, explosive eruptions, so not all volcanic eruptions, but large volcanic eruptions that inject sulfates into the stratosphere, which then circulate hemispherically or globally, reducing global temperatures, that is, reducing solar radiation reaching the Earth. And that is the driver of the suppression of the ITCZ, essentially, this teleconnection, therefore, between volcanic eruptions and the East African monsoon. There is a literature on this that we have tied into. A few articles coming out in the 2000s, 2006, the classic one here by Luke Oman, and others with really an important article. And now there's more recent work, but this is essentially the literature now that we're tying into, which was, I think, basically unknown, certainly by Egyptian historians and Egyptologists until very recently. In fact, it has been known in the climate literature, but the consequences of it have not really been explored. And that is the essence of our project, basically. Another article that came out recently on this teleconnection between historical Egyptian famines of the last 1,000 years and Nile River flow, not really stressing the main driver, we think, which is large-scale volcanic eruptions. In the short term, this is a major driver. There are other drivers of Nile River variability, including the El Nino, or the El Nino Southern Oscillation, as it's called, ENSO. But volcanic eruptions really look like the main short-term driver of Nile River variability, and that's really rather exciting, I think. I don't need to get into the science too much. Number one, I'm not a scientist. I'm used to explaining science now, which is maybe somewhat dangerous sometimes. But the basic mechanisms of large-scale eruptions and the impact of the reflective nature of sulfates in the stratosphere, reflecting solar radiation back into space, not reaching the Earth and creating cooling, and therefore perturbing the East African monsoon. This basic geochemical mechanism, I think, is pretty well established now. What's interesting and what's an important reminder is we haven't experienced a large-scale eruption in the world that perturbs the intertropical convergence zone really since Pinatubo. And I show on the right photographs of Mount Pinatubo in the Philippines, which is already 1991, so quite a while ago. So I think we tend to forget that really large eruptions, particularly at the right time of year, and that is important, are drivers of things like Nile River flow, but actually of drought, lots of places in the world. So we're living in a relatively quiescent period historically of volcanic eruptions, large ones, and they're likely to return again, which we should be concerned about. Okay, this paper that came out in Nature in 2015 is the origin of our project. I think it's the most important paper in the last many decades for ancient history and archaeology. I'm not trying to be too dramatic, but this is fundamentally an important paper. And I saw a preprint of this in 2015. And literally I fell off the chair because I couldn't believe the volcanic peaks I was seeing and recognizing some of the peaks historically that correspond to periods of social unrest in Egypt very well. And it just seemed like there was this amazing connection. So this is the origin of the paper. The important thing about the geochemistry of this paper is it revises the volcanic chronology. And now we have a full Holocene reconstruction of volcanism by Michael Siegel and Matt Toohey that came out last year. It revises the dating of volcanism in antiquity by roughly 8 years systematically. Now, why is that? Well, there was a tie point in Greenland ice cores that the Danes believed corresponded roughly to Vesuvius in AD 79. And it turns out that was incorrect. It turns out that it's a Japanese eruption in 88 BC, or 88 AD, sorry. So almost a decade off. And that was a tie point for the chronology. So once that's removed, the chronology changes fairly substantially, I think. And if you're an historian like me, who has dated records often to the day, the month, and the year, a volcanic sequence that's off by a decade, you can't use. Even if you thought ice cores are telling us something important, you couldn't use the ice core record until 2015. And the other thing that I find amazingly fortunate about this paper is you'll notice for the past 2,500 years. Now, there's a lot of climate data that's only 2,000 years or 2K. Because it's a nice round number, I think, and climatologists in the past haven't been thinking about history or humans, indeed. So 2,000 years is as good as any other sort of thing. Michael Siegel brilliantly went back 2,500 years because he could, because the record allowed that. And it opens up for me, of course, the last 5 centuries BC, which is the period I happen to work on. And that's the exciting thing about this paper, I think, indeed. The reason this chronology is so secure now, I think, is that the tree ring record, and here's the combination of a composite tree ring record above and the record of volcanism below, with the dotted line being the scale of Mount Pinatubo, by the way, that scale of eruption. And you'll notice that the cooling response and the precip response of the tree rings in composite now line up beautifully with the volcanic record. So I think that's pretty good evidence that the new chronology is actually pretty tightly constrained now, as opposed to before 2015 when it wasn't so much. You'll also notice, just briefly, by the way, that the Hellenistic period, the last few centuries BC, is pretty volcanically active compared to the Roman period, which is the Roman Empire, which is indeed fairly interesting. I won't say too much more about it, and I won't draw any historical conclusions about it, but I do note it. I think it's relatively interesting. Okay, how does our project work? Well, we actually happen to have a decent Nile record, we think, recorded at Rhoda Island from 622 AD to 1902 AD, the Cairo Nilometer record, as it's called, which is very well known, of course, and records for most of these years, a 1,300-year record, the high and low stands of the river at Rhoda Island. A lot of historians, of course, know about it, have been wondering, is it really accurate or not? Does it really reflect true Nile river flow? And one of the things we did in our first paper is actually argue that the Nile record at Rhoda is actually a pretty good record of Nile flow because it corresponds, again, rather beautifully to the volcanic record in that 2015 paper. That's the essence of our paper. And it would not be a made-up record or a fanciful record showing the volcanism systematically, if that makes sense. So we think that the new volcanic record confirms that the Cairo Nilometer record after 622 is a pretty decent record of Nile flow. And if we're correct, that's important for our work because we can work backward from the Nilometer record into the Ptolemaic, into the Roman period. And that's what we've begun to do. We published a paper last year on Okmulgee in Alaska in 43 BC, and the entire decade now from 43 to about 33 BC, of course, an interesting period historically, is rather opened up in terms of at least the question, what role does sudden climate change and Nile River failure, indeed, and much heavier rain and cooling in the North Mediterranean, what does that do to human or societal responses, basically? Okay. Oh, I'm sorry. The fortunate thing about Egypt, of course, is we have quite a lot of papyrological records in the Ptolemaic period, the Roman period too. In the Ptolemaic period, on the left here, a beautiful Demotic Egyptian contract. On the right, a Greek text, a letter from the Xenon archive in the middle of the 3rd century BC. We have quite a few, of course, thousands of dated documentary records from this period. And this is what we're using in our work that goes back to earlier historical work by Danielle Bonneau. Of course, the papyrological record is sometimes rather interesting. Below here, just a snippet of a famous Greek text, middle of the 3rd century BC, that talks about the invention of some sort of new irrigation device or machine, perhaps an improvement of the Sakia. A water wheel, we don't quite know, but it's a rather interesting text. Historically, it mentions a river failure, no flood for 3 years in a row. And no one's done anything with this text because you can't really do much. The text is not dated specifically. From the handwriting, people make some guesses. From the context, middle of the 3rd century BC is probably correct. But we think we can date this text now from our Nile River reconstruction, which is rather exciting, to the 240s BC. So here it is. Again, here is the volcanic record showing the volcanic peaks measured in terms of the concentration of sulfates in the ice as a proxy for the size of the eruption. Here is this large eruption, used to be thought 44, used to be thought perhaps Etna. It's 43 BC, it's winter 43 BC, and it's Okmuk in Alaska, and that is certain, I think, in both cases. And by the way, this is not to scale. If to scale, it would be up here somewhere. This is the largest Northern Hemisphere eruption in the last 2,500 years. So we begin to put an historical record onto the volcanic sequence, which we think is telling us something about Nile River flow. And just visually, of course, things like periods of social unrest, very well documented in the papyri, these X's, and the volcanic sequence here looks, at least visually, of course, like it's correlated. And we've done a lot of statistical work now that shows that it's highly correlated, above 98% confidence, that there's a connection somehow between periods of social unrest and Nile River failure. And what we're doing is now not working in an annual sort of scale, but we're trying to identify decades like the late 40s BC, 30s BC, and the 160s BC as periods of particular problems in Egypt. And of course, you all know the 160s BC, that decade, is a rather interesting one in Eastern Mediterranean history in many places. Now, here's one of our heroes, the great scholar Danielle Bonneau, who dedicated her life to understanding the Nile River, the culture of sort of human responses to the Nile River flood and so on, but also the record in the papyri, in the Greek papyri of Nile River conditions in her famous book, Le Fisc et le Nil. You know, a lot of historians use it still. It's sort of what we have as a record of Nile River flow. This is her coding here in French from bad to really strong flooding. And she sort of converts it to Roman authors' flood records of good and bad floods in cubits and so on. And then she has these famous tables where wherever she has a year with a good Greek papyrus record, she says, well, okay, this is a mediocre flood in that year. And this is what scholars do. If you have a text in 258, you go to Bonneau and say, well, what's the Nile doing? Well, looks like it's pretty bad. But of course, this is qualitative and it's one record from one place and from not every year. basically, for the Ptolemaic and the Roman period. But this is what we had until our project. What we've done now, thanks to my graduate student, Joe Morgan, is we have thousands of records coded, and almost every year, the last 3 centuries BC now, and usually more than one text and Egyptian language material as well as Greek material. We've coded it independent of the Bonneau book, just to sort of see if the papyrus record really does indeed show Nile River variability in a qualitative way. We've done some qualitative coding. We've done some uncertainty here, and we're working with this now quite a bit. I think it's a pretty valuable database that we're just beginning to analyze. I'm sorry you can't really see the text here, but the basic work we did in the 2017 paper is use the Cairo-Nilometer record for 1,300 years and the volcanic record together, and it shows that on average, the mean reduction over 1,300 years in year 0, which is year of an eruption, is about 20 centimeters of Nile River flood, essentially. Now that's mean reduction over 1,300 years. If you do specific volcanic eruptions in the Northern Hemisphere, it's 3 times that amount. So it begins to become significant. All this shows us statistically is the Cairo-Nilometer record shows a response to the volcanic sequence, essentially, statistically, using a Monte Carlo simulation with a million different draws, with eight-year window before and after an eruption. So it's a pretty decent statistical analysis, I think, of the volcanic record. We've done the same thing initially now to our new database, and the red are volcanic years, the black are non-volcanic years. This is ranked flood in the Ptolemaic period, and what this shows us, I think rather remarkably, is, and preliminarily, that the papyrus record that we've constructed now also shows that volcanic years have lower flood quality than non-volcanic years. So the statistical results, at least preliminarily, look pretty decent to us. We have a lot more work to do on that, but just we wanted to test it this year to see what our database looks like. And for example, just as a way of how we think when we have a lease of agricultural land in a specific year in a specific place, we think that leases of land are made in the light of the flood of that current year, and therefore are proxy records of at least an average sort of flood. And that's what the statistical analysis is showing us here in our database, that in lease years, the flood is better than in a year where we don't have a lease. So we know there's problems of survival of evidence and so on, but just from what we've done, it looks like a pretty decent record. I'm happy to talk about that as we go on, or at the end, I should say. Okay, so our decadal study here, these are the decades we're interested in: the 240s BC, the late 3rd century BC, the 160s BC, and the 40s, 30s BC. These sort of decades where we have a sequence of volcanic eruptions, not just one, because one eruption, even a large one, is going to perturb the Nile for a year, maybe 2, depending on the time of year of the eruption or so. But a sequence of eruptions closely spaced together might do other things. And that's what we're looking at with the 40s BC from our work so far in the Okmuk eruption here, a climate model response, which is showing what we think happens, thankfully. That is, the East Africa dries out. It gets wetter and cooler in the northern part of the Mediterranean, with the westerlies from the Atlantic system driving the Mediterranean climate into the Near East and up into the Taurus range. So it's a decent, I think it's a decent model response. Now, for the 160s BC, and I'm almost done, I'm looking forward to comments and questions. We just have published a preprint paper, so you're welcome to have a look at it. It's in the special issue that VIX is running in the journal called Climate of the Past, on volcanic impacts on climate and society. And here's the paper investigating hydroclimate impacts from 168, 158 in the volcanic quartet, led by our postdoc at NASA GIS, the Goddard Institute for Space Studies in New York, and Columbia University as well. So this is a climate modeling paper, and we're now writing an historical paper on the 160s based on what the climate model is telling us. And these are preliminary results, of course, but rather exciting. This shows us the mean solar radiation reduction in the volcanic sequence, the historical sequence we have in the 160s BC from the ice core record. One very large one, Northern Hemisphere, and then three smaller eruptions closely spaced together in the tropics somewhere, Philippines, probably, or Indonesia. And so, over this decade, here's the solar radiation response. It's reduced, and that has an impact, we think, on the monsoon. And you can see it here in this Hofmahler diagram, zonally average temperature dispersion from 169 to 15, whatever that is, 154 BC. So over the course of a decade, a little bit plus, you can see the pulses of 4 volcanic eruptions here. And you can see in this model, or in this figure, I should say, the drought, basically, the rainfall reduction here with these 4 plots, which so the model is doing what we would expect it to do where we think it's important, that is in East Africa around Lake Tana, basically. So this is rather exciting. I think this is a brand new information, and we think there's probably a heck of a lot of historical work to do now globally, we think, on this sequence of 4 different eruptions. Now, in terms of the historical record, let me end with that. Of course, we have in Egypt a lot of papyrus records and some famous ones in the 160s BC, this really rather well-known letter of a wife to her husband, essentially saying, "Where are you? We are surviving, your child and me, in such bad times, driven by extremity owing to the price of wheat. We thought you'd be home by now, but you haven't returned home yet. And it's really a really nasty time." This is 168, just after the first eruption. So possibly in the year of very poor Nile flooding. It makes sense that this stress we see in a letter like this corresponds to Nile River failure, of course. And again, as you all know, in the 160s, there's so much happening in the Mediterranean world, including in Egypt. The 6th Syrian War, 2 invasions of Antiochus IV, including the important famous one in 168 BC. At the end of the decade, we can see fiscal responses to what looks like a really bad decade. A new organization of the entire state fiscal system, for example. At the end, a priestly decree in 161, which is a sort of settlement between the priesthoods of Egypt and the Ptolemaic kings to reestablish order. And in 165 BC, I think the most remarkable historical document we have from the entire Ptolemaic period, dated 165 and 164 BC. We call it a treatise on agriculture. It's an administrative text sent around the state in response to a statewide crisis. And the Greek language here is extraordinarily harsh, and very, very unusual to see such harsh, stark language in an administrative letter. It's rather sarcastic. So essentially what happened was in 165, the state fiscal, the head of the state's fiscal system is observing that the irrigation system is in complete disarray, and the agriculture is in danger of failing statewide. And he sends out an order to get people into the countryside, to get the irrigation system working, and to get farmers farming land again. Otherwise, we're in danger of a famine statewide, basically. And so this is really interesting because it suggests a great deal of stress in Egypt. This text has always been seen as kind of a literary treatment rather than something particularly serious. But we think this is actually reflecting the realities of the 160s BC, when there was multiple years of Nile flood suppression, if not outright failure, and serious economic problems. Even in the Babylonian astronomical diaries, this kind of shock in this volcanic sequence here, here's the volcanic sequence again, severe cold is observed, which is rather unusual language in the Babylonian astronomical diaries. Here's our documented flood failures in these years, in these pyramids, and a sequence of other sorts of events. They all look like they line up rather well together, we think. So not just Egypt, but even in a place like Babylon, reflecting the much colder weather, and even in a couple of cases, dust veils, which might well be volcanic dust veils that's observed by the priests in Babylon. And spectacularly, I think, and we're just exploring this in China in the same years, in the 160s BC. I'm sorry, this is fuzzy, but in the Chinese annals, the same kind of administrative response, agricultural failure, fairly wide scale, and administrative sort of panic about what to do about it. We think that's probably the East Asian monsoon suppressed or failing altogether, which is what we'd expect from the volcanic sequence. So it's not just in Egypt, but it is possibly monsoon-wide problems, a global crisis of some kind, of some scale throughout the 160s BC. We're doing hydrological modeling, just to wrap up here, Jim Staggy at Ohio State, based on the modern British record in the early 20th century, and then using now the Islamic period record and the historical record to reconstruct Nile River flow on the floodplain. Yes, it's modern data, of course, but we can begin to understand the river dynamics. I think for the first time, what does the flood look like on the floodplain? Of course, it's regional in Egypt. It's not all the same everywhere. Some places in a normal year will get water, other places don't. In a bad year, there's still a flood in some places, but not all over. That's what we're trying to understand, a regional dynamic, a local dynamic response. And what's so interesting is this we just produced this week. We can map on now from the papyrus record. This is Joe Morgan's work again. Every village and town recorded in the papyri and the historical Nile River flood. And it's rather remarkable. These are the villages and towns we know about historically here, these dots. And it's more or less showing what we think historically is the case, that villages and towns are located on higher lying land above the flood basins. And this the flow record and the historical record really reflect that rather well. So once we begin to enter historical data from our database, at least qualitatively, and understand river flow historically year by year in the Ptolemaic and the Roman periods, I think we're on to very exciting kind of dynamic historical work. And finally, I know you're talking about memory in your seminar. The most famous literary text from the period is the Oracle of the Potter, certainly one of them. The texts we have are 3rd century AD. They're in Greek. They're in Vienna primarily. And of course, well known, and this is just the sort of beginning of the text, always treated as kind of allegory about a sort of anti-Greek response by Egyptian priesthoods, not liking the Ptolemies and talking about apocalyptic conditions. But actually, if you look at the text literally, like I do, because I'm a literal guy, the river, it doesn't have sufficient water. It doesn't flood. The earth is scorched unnaturally. The sun is darkened, not willing to observe the evils in Egypt. The earth will not respond to seeds. The farmer is still pressed for taxes for what he didn't plant. There's infighting in Egypt, that is social unrest. And there's an invasion by the king of Syria. This is Antiochus IV and so on. This looks to me like an actual literal response to the volcanism that we can see in the volcanic record, including possibly even dust veils that are being observed. So this may well be allegory as well, of course, but this entire apocalyptic text looks like is a kind of literal response to what happens when you have large eruptions and now flood failure and the internal problems. The entire mechanism, in other words, seems to be here in this prophetic text. Interesting that the text we have it, even though it's a Ptolemaic period text in composition, what we have are 3rd century AD copies. And it's exactly the time when we get large scale volcanic eruptions starting again. And it's rather tempting to understand that as being connected. Thanks a lot. I look forward to comments and questions.
so much for this fascinating and indeed exciting talk, which I need time to let it sink in, but other questions?
I'm going to stop sharing for now, if that's okay.
Sure. So are there any questions concerning?
Yes, I have a question.
Yes.
First of all, thank you very much for your lecture. I would like to know if we have any historical records where it's the opposite, where there is no social unrest, but there's actually these volcanic eruptions are actually doing something positive for the climate. Maybe you mentioned it and I didn't understand, but in Israel, for instance, or in this area, after volcanic eruptions, we have more rain, and it's actually, it can be better for the agriculture. So if you said it and I didn't understand, I'm very sorry. Or I didn't hear.
No, that's a great question, and of course, we're looking now in the historical work we want to do on periods of social unrest that are not related to flood failure. Of course there are. It's not the only driver of social unrest. So we're trying to understand the connection between short-term flood suppression or failure in some cases, in particular decades, which we know are pretty bad decades, for example, and other times when there's no connection. 70% of years are probably normal years in Egypt. We know that from the Nilometer record. So already that's a good assumption. So high water is tough to see, or higher water. We're looking at a range of what's called normal flood, of course, and I'm hoping with the hydrological model that we're going to have working this spring, that we can begin to see what happens on the floodplain in years that are very good as opposed to average or a little bit below average, and sort of see the dynamics. They must be there. The exciting thing is this has not been understood dynamically before. We just have, sort of static information, and we don't see patterns. I'm hoping we can see patterns, connections. We don't think flood failure or volcanoes are the only thing for sure. It's more complicated than that. And I think the climate work forces us to be better historians. So, we are thinking hard about the total system here. Yeah. What we don't know, one more thing, with what happens with when the Nile, when the ITCZ doesn't move north, we get more rain in the White Nile system. So the rainfall sits at the equator and it stays at the White Nile source. So that's going to produce more water in the non-agricultural, non-summer months. The question is, can that be used at all if it hits Egypt? There's a lot of evaporation in the Sud, of course, from the White Nile. There's a lot we don't understand. What does it do for disease? Another sub-project that's being worked on by Mark Macklin in England and others is the connection to malaria, which is endemic in Egypt, but there are outbreaks that are serious. So that connection hasn't been really explored. I'm excited by it, and I hope that project really takes off, because that's another component to this kind of work.
Thank you. Other questions? Well, we are the Institute of Archaeology. We deal a lot with the second millennium. Is there anything you can say about earlier periods?
Oh, Bronze Age collapse. Yeah. Well, yeah. So, of course, if we're correct that we are beginning to understand the river dynamics, these are going to be there in the Bronze Age. There are problems with dating. So Joe McConnell, the ice core geochemist in Reno, Nevada, at the Desert Research Institute, is our main ice core guy. He's a brilliant scientist, and he's now getting some seasonal records in the first few centuries BC which is why, we're excited that Okmuk is winter 843 BC. That's important. The further back in time, there's more dating uncertainty in the volcanic record and the ice cores so far. So there's more, it's a little bit more problematic. On the other hand, we have a great volcanic sequence in the 12th century BC now, including 2 rather large eruptions and a series of smaller ones that were tempted to connect to the problems that are well known in Egypt, the strike at Deir el-Medina, the grain price spikes in this period, the assassination indeed of Ramses III, all in the space of about 5 years in the 1150s BC. Rather interesting. And, we have a draft of a paper we're not sure what to do with because it's, we just have some thoughts about it. So, yeah, I think the dynamics are there. The Bronze Age, at the end of the Bronze Age, clearly there's some climate things happening in the Eastern Mediterranean that are drivers of things like migration and longer term drought. That looks pretty good. Some of it may be triggered by large eruptions, so it's a component perhaps of the drought that archaeologists and others are seeing. Yeah, but I'm being rather fuzzy. I'm hoping the dating gets better in the ice cores. I'm hoping the tephra analysis gets better so we can identify specific volcanoes. That is a new science. Okmuk in 43 BC is as far back as we can go in the ice cores with tephra and fingerprint a specific volcano. So there's a lot of work to do yet, and it matters where the volcano is located, as well as the time of year the eruption happens. So large eruptions don't always do anything to the global climate system. We know that. The time of year matters, certainly in the Nile.
Right. Thanks a lot. Other questions?
Mm-hmm.
Maybe in the chat or no?
In the chat, yeah. And
Okay.
by the way, the cuneiform is in the room. You should tell me what you see in the cuneiform record with response to the Atlantic Westerly system up in the Taurus in the Euphrates record. We're noticing some things from the Babylonian diaries, which are really interesting, but of course they're middle 1st millennium BC forward.
Right. Yeah. There's another question. The skull? No.
Yeah, I'm seeing Yuval Gado's question. Yeah, of course. Is there a connection with Maccabees? I've never seen any study of drought. I think there's some vague references to drought in our sources. I think there are very good speleothem records that we would like access to that are known, some of them unpublished, but it'd be nice to see if there's any kind of drought pattern or rainfall patterns that might make sense in terms of things in and around Jerusalem in the 160s BC and afterwards. That would be nice to see.
Right. There was another question here.
I was just curious if you saw something in the more modern Krakatoa eruption, how you could see how that affected the.
Sorry, Krakatoa?
Yeah.
Yeah. So Krakatoa, I think, erupts in June. Am I right about that? And it looks like there's no Nile response to Krakatoa, if I remember correctly. Of course, the Nile's already flooding in June. So an eruption in June will do nothing to the Nile flood in that year because the Nile's already in flood. And then the question is what the climate models are saying in year 2, the second year after an eruption. And sometimes Okmuk, for example, in 43 BC, that produces a decade of cooling. If you read our paper, that's spectacular. cooling response in the Northern Hemisphere. But most eruptions are maybe a year or two at maximum, which is why we're interested in volcanic sequences, 3 or 4 eruptions closely spaced. So if I remember correctly, Krakatoa was a pretty big eruption, but no impact on the Nile flood that year. And of course, the big one in the 20th century, what's called now Nova Erupta or Katmai in Alaska in 1912, a very large eruption. For example, it does produce a response on the nilometer record in 1913. But of course, the British had built the low dam in 1902 and actually had raised the low dam in 1912. So Egypt in 1912, 1913 was insulated from the impact of Katmai, which is the largest 20th century eruption. But the Sudan wasn't. And there's famine in the Sudan in those years, which is interesting. So that's a resilient response, maybe unintended, but Egypt was importing food into Egypt again in 1912, 1913. So it was insulated from such a natural shock as a large eruption.
Other questions? No. Okay, so we'll let you go and have breakfast.
Yeah. Okay. Well, thank you.
Thanks a lot for this. And yeah, see you.
Thanks, everybody. Yeah, I hope I can come meet you all soon. Be well in the meantime. Thanks.
Yes, you will. We hope so. So again, thank you so much.
Yeah, thank you. Thanks.
Before we leave, one sentence in Hebrew. You've seen it already on the screen. ההרצאה של דוקטור דפנה לנגוט תוקדמה בשבוע, היא תהיה שבוע הבא. את הכותרת אתם ראיתם, אני גם שלחתי לכם את הפרטים במייל. אז אוקיי, אז ניפגש כאמור שבוע הבא, כאן באופן פרונטלי להצעה של דפנה. תודה רבה, thanks again. It was very illuminating.
Thanks.
I'll be reading all the stuff now.
Okay. Stay in touch, everybody. Thank you very much.
Thank you.
Thank you.